So, hi students. So now we will discuss few problems on thermal expansion. In thermal expansion, okay, solids we have seen. We will do some problems on that, and the thermal expansion in liquid we have seen certain points. So that also we will discuss in today's this session. Okay, right. So our first question: a steel wire of cross-sectional area 0.5 millimeter square is held between two fixed supports. If the wire is just taut at 20 degrees Celsius, determine the tension when the temperature falls to 0 degrees Celsius. Okay. Coefficient of linear expansion of steel and its Young's modulus is also given. So we know what they are asking. They are asking the tension. So we know Young's modulus is what? Stress by strain. So force is in the formula of stress. So stress is equal to Y into strain. So force is F by A. So no, stress is F by A. So force is equal to area into Young's modulus into strain. Here there is temperature difference. So heat is involved here. So when heat is involved, then there is going to be thermal strain. So thermal strain is what we have studied. New length is equal to odd length into 1 plus alpha delta theta. So from this, L minus L naught divided by L naught is equal to what? Alpha delta theta. This is what is thermal strain, alpha delta theta. So here alpha delta theta can be given. So what is area? Area is given as 0.5 millimeter square. 0.5 into 10 raised to minus 3. Okay. So for 1 millimeter, this is how. Now its square we will have to take since it is area. Into Young's modulus is given as 2 into 10 raised to 11 into coefficient of linear expansion of steel is given as 1.2 into 10 raised to minus 5, okay, into the change in temperature is from 20 to 0. So change in temperature is 20. Okay, so when you expand this, when you simplify this, we will be getting around 24 Newton. So this is the answer for this question. Option B. Clear? Okay. Shall we move to next question? Yes. Another question. Another question is a steel scale is calibrated for 20 degrees Celsius is used to measure the length of a rod at 30 degrees Celsius, which is 30 centimeter long. Okay. Find the observed reading of the rod. Okay. And the coefficient of linear expansion of the steel is 1.2 into 10 raised to minus 5 per degree Celsius. So here the steel scale is calibrated for 20 degrees Celsius means it will give correct reading at 20 degrees Celsius. But here it is used to measure the length of a rod, and the rod is at 30 degree measure of the rod at 30 degrees Celsius means The steel scale is calibrated to use at a 20 degrees Celsius, but now it is using at 30 degrees Celsius. So obviously the steel scale, okay, its length will be increased because of change in temperature. Okay, there is no we must assume that, understand that the length of the rod will not change here. Okay, only steel is the length of the steel is changed. Okay, or otherwise they will mention in the question like the length of the rod is also changing at such temperature. Now the data is like calibrated for using at a 20 degrees Celsius. Now it is measured at a 30 degrees Celsius. So the original length of the rod is given as 30 centimeter. Now what is the observed reading? Observed reading. So true reading, already we have studied. True reading is equal to what? Okay, or measured length. Measured length is equal to real length minus the change in length. Okay, true reading or not true reading, observed reading, we can say this is observed reading or measured length. Observed reading. Observed reading, that is now when it reads at 30 degrees Celsius, this is going to be real length minus the change in length. Okay, so what they are asking, find the observed reading. Yes, right. So real length is how much? 30 centimeter minus the change in length is what? Change in length is L alpha delta theta. Correct or what? L is equal to L naught into 1 plus alpha delta theta. So from this, the change in length, that is L minus L naught, is going to be L naught alpha delta theta. Okay. So if we, this is L naught alpha delta theta. So what is L naught alpha delta theta? So this is 30 centimeter minus the original length. What is the change in length? 30 centimeter into we will find this. Okay, the change in length is equal to L naught alpha delta theta is equal to 30 centimeter, okay, divide by 100, okay, to convert into meter, into 1.2 into 10 raised to minus 5 into the change in temperature is 10. So if we measure, we simplify this, we will be getting this as 3.6 into 10 raised to minus 5. So here we can substitute 3.6 into 10 raised to minus 3 to make it into centimeter. Okay, so if we subtract this value, we will be getting 29.9964 centimeter. Okay, so this is going to be the measuring length or the reading which is going to be observed with this wrong length of the scale. What they are asking is observed reading. Okay, so this is not the real length. The observed reading will be this one. Real length is given in the question. Okay, so this can happen if the temperature is going down, the observed reading will go up. Okay, okay, clear. So our next question is, a glass vessel of volume 100 centimeter cube is filled with mercury, okay, and is heated. So initial volume of vessel as well as the liquid is 100 centimeter cube, and it is heated from 25 degrees Celsius to 75 degrees Celsius. What volume of mercury will overflow? We need to understand the apparent change in the volume. Okay, so the volume of liquid overflow is equal to the apparent change in the volume of liquid. This is equal to what? We have seen a formula. V naught into delta theta, that initial volume into change in temperature, okay, into what? The coefficient of volume expansion of liquid, okay, the real real coefficient, okay, not apparent one, minus the coefficient of volume expansion of vessel. Okay, so this is the formula we have studied in that topic. So this one, if we apply, this is going to be 100. Since the answers are given in centimeter cube, I am maintaining like that, 100 into delta theta is 75 minus 25, change in temperature is 50, and coefficient of uh, linear expansion of glass is given, coefficient of volumetric expansion of mercury is given. So that is 1.8 into 10 raised to minus 4. So this is for mercury, gamma of liquid, minus this one. Please be careful. This they have given linear expansion. Linear expansion is alpha. So gamma is actually 3 alpha. So here we will have to multiply 3 into 1.8 into 10 raised to minus 6. So if we simplify, we will be getting the answer as 0.873 centimeter cube. Option D. This is the correct answer. Okay. Next one. So they have given like two absolute scales A and B have triple points of water defined to be 200A and 350B. So what is the ratio of TA is to TB? That is the question. So this is the topic, from the topic triple points. Okay, what is triple point? Where the solid, liquid, gaseous, all these forms exist together. And for water, we know, we have studied, this is the triple point is at 273 273.16 is the triple point of water in where in Kelvin scale. In Celsius scale, it is going to be 0.1. Okay, so here they are mentioning like two absolute scales, A and B. So this is not Celsius or Kelvin, but they have given like two scales which are A and B. We do not know about that scale in detail. Okay, but they are said that, okay, in that scale, triple points are at 200A and 350B. We need to find the ratio of TA and TB. Okay, so how to do this problem? So here, okay, so triple point. Okay, you can try. You can pause the screen and you can try yourself. Okay, so we can do like this. Triple point in on scale A. Triple point on scale A is how much? 200A. Okay, that is given. Now triple point on scale B, this is given as 350B. 350B. Now triple point of water in Kelvin scale is what? This is 273. We know its value is 273.16 Kelvin. Now all these are same actually. Okay, okay, this is same as 200A, this is same as 350B. Now if 200A is equal to 273.16K, 200A is same as 200A, that is in different unit. 200A is in different unit. This is same as 273.16 in this unit. Okay, both are same. Now just like we do 180 degree is same as pi radians, right? 180 degrees same as pi radians. So we have taken like 1 degree is equal to what? Pi by 180. We have used it like that. So 30 degree will be pi by 180 into 30. Same thing we will apply here. I can write 1a. Okay, 1a. Before that, I will write that also. Okay, so here 200a is actually what? 273.16 Kelvin. So 1a is equal to 273.16 Kelvin divided by 200. So I could write a temperature, okay, Ta is equal to 273.16 divided by 200 into Ta. Correct or what? Same way, same way, I could write. They are asking what the ratio of Ta and Tb, ratio of Ta and Tb. They are asking, or relation between Ta and Tb. Okay, same way we can write 350B is equal to 273.16 Kelvin. So 1B is equal to 273.16 divided by 350. So TB is equal to 273.16 divided by 350 into TB. Clear or what? Okay. Now what shall we do? Um, what is this actually? Okay. Now what we need to find the ratio of TA and TB. So we will take the ratio of this. Okay. Okay. Fine. So 273.16 divided by 200 into TA. This is equal to 273.16 divided by 350 into TB. What is this actually? This is, why this is equal? Because they are triple points. Okay, this is what? Triple points. Okay, so this is triple points. Okay, so we can equate this. Okay, 273.16 Kelvin is the triple point in Kelvin. Okay, TA and T 200A and 200 350B are the triple points in that scale in A and B. Now, if we are converting, okay, triple points in TA and TB like this, then they are equal. Now we will take the ratio of this. If we 273.16 can be cancelled. So TA by TB is equal to what? 200 divided by 350. So if we solve this, we'll be getting 4 by 7. This is the answer for this question. Okay, 4 by 7. Option C is the correct answer. Clear? I repeat this question again. Two absolute scales A and B have triple points of water defined at 200A and 350B. Now they are asking what is the ratio of TA and TB. Now we know 200A is the triple point in scale A, 350B is the triple point in scale B, 273.16 Kelvin is the triple point in Kelvin scale. Now 200A is equal to 273.16. Okay. Now what we are doing? We are taking one unit, then multiplying with the value TA. For the same TB also we are doing the same thing. Then since they are triple points, we are equating it and solving this. Okay, clear? Okay. Next question. So two ideal gas thermometers A and B use oxygen and hydrogen respectively. Okay. The following, okay, two thermometers. In one thermometer, they have used oxygen Okay, gas thermometer. So inside gas will be there. Another thermometer they have used hydrogen. Okay, and the following observations are made. What are the observations? One is triple point of water. Okay, the pressure on thermometer A is given. That is the pressure corresponding to triple point of water. And for triple point of water, the pressure corresponding to thermometer B is also given. Okay, that is one thing. Another observation is normal melting point of sulfur, that corresponding pressure is given. Normal melting point of sulfur for uh, the pressure corresponding to that one is also given. That is, suppose if we take a thermometer, suppose if we take a thermometer at a triple point of water, if we are keeping at a triple point of water, if we maintain this thermometer, its pressure it will show. That is what is we have taken the reading. So thermometer A, another thermometer B. Then when sulfur is at a normal melting point, that time also we kept the thermometer there. How much pressure reading is here, that also we have measured. That is what these readings are. Now what they are asking, what is the absolute temperature of normal melting point? They are asking the temperature of a normal melting point of sulfur as read by thermometers A and B. Now they have given only pressures. Okay, we need to find the temperature of normal melting point of what? Sulfur. Okay, now we will take one by one. So first case, if we take thermometer A, if we take thermometer A, so we have seen the ideal gas equation, PV is equal to what? nRT. So in this, what all things are constant? Volume is constant in the uh, thermometer. Volume is constant. The content also we are not changing. So number of moles constant, and this is universal gas constant. That is also same. So P by T is equal to what? Constant. Okay. So P by T is constant, and what they have given is first data is triple point of water. So pressure of triple point of water divide by temperature of triple point of water. This is equal to P by T is constant. We will take the pressure at a normal melting point of sulfur. So pressure at a melting point, okay, of sulfur divide by the temperature of melting point of sulfur. Okay, so this is normal melting point means that is how the pressure everything is clear. Now all these datas are there, what, except the temperature, so we can find it out. So when we substitute the values, we will be getting 1.25 into 10 raised to 5 divide by its temperature is 273.16. This is triple point temperature. This is equal to 1.797 into 10 raised to 5. This is the pressure at a normal melting point of sulfur divided by the normal melting point temperature. Okay, so TMP, okay, if we calculate, we will be getting 392.69 Kelvin. Okay, this is the with the first thermometer. Now we will consider thermometer B. Thermometer B. Okay, so pressure of thermometer divide by pressure at a triple point, okay, of thermometer B. Then temperature of what? Triple point. This is equal to pressure of sulfur. Okay, okay, pressure of sulfur at a melting point divide by temperature of sulfur at a melting point. So what about this pressure of triple point of water is how much at a thermometer B? 0.200 into 10 raised to 5 divided by 273.16. This is equal to, the pressure is 0.287 into 10 raised to 5 divided by the temperature of melting point of sulfur. Okay. Now we will calculate this. So temperature of melting point of sulfur. So this one is A, this one is for thermometer B. So we can calculate this and we will be getting 291.98 Kelvin. 291.98 Kelvin. Okay, so that is the question. What is the absolute temperature of normal melting point of sulfur as read by thermometers A and thermometers B? That is the question. So these are the values. Now, now here one value, that is the thermometer A, shows 392.69 Kelvin and thermometer B shows 391.98 Kelvin. Okay, why this difference? Why such a difference? If you look at the data, what is the pressure? The pressure is 1.250 into 10 raised to 5 Pascal. Okay, then 1.797 into 10 raised to 5 Pascal. Okay, this is high temperature. This is high temperature. And triple point of water, we know triple point of water is very low temperature. Okay, so high pressure and low temperature we can see. So the deviation is because at low temperature and high pressure, okay, what will happen? The gases will not obey ideal gas equation completely. There will be deviation at the low temperature and high pressure. There will be deviation from ideal gas equation. So we are using PV is equal to nRT. So because of that, we are getting small difference here. How much? 392.69 minus 391.98, less than 1 Kelvin. Okay, less than 1 Kelvin difference only. Okay, or around 1 Kelvin difference we can say. So why this difference is because gases obey ideal gas equation. Gases obey ideal gas equation only at high temperature and low pressure. Okay, so till for and moderate temperature, moderate pressure also it will be okay. But if the temperature is very less and the pressure is very high, in all these situations it will deviate from the ideal gas equation. That is the reason we are getting like this. Okay, so that's all about the thermal expansion of solids and liquids. So just for an understanding, we have done some problems. Okay, then thank you, goodbye, good luck.